behavior of copper prices. After reaching a level of about $1 per pound in 1980, the price of copper fell sharply to about 60 cents per pound in 1986. Price decreased greatly. Copper price decreased greatly in mid-1980s. Worldwide, why that happened? Worldwide recession in 1980 and 1982 contributed to decline of copper prices. So in 1979, 1980 is featured by second oil shock. Oil price decreased greatly, leading to worldwide recession, right? So because of this, demand for copper fell sharply, decreasing, leading to decline of copper prices. Why did the price increase so sharply after 2003? But after mid-20th century, year 2000, price of copper increased greatly. So economists said there are two factors increasing copper price. Number one, the demand for copper from China and other Asian countries began increasing dramatically. Okay, so so everybody knows that the concept of China rise, right? Manufacturing industries in China grow greatly. Also, lots of ASEAN countries, East Asian economies grew rapidly, more rapidly than other regions, right? So because of this, demand for copper increased, right? That is number one reason why copper price increased in mid-year 2000. Second factor is this, because prices has dropped so much from this period before that. Producers closed unprofitable mines and cut production. What do the decline in demand do to the price of copper? To find out, we can use linear supply and demand curve, right? Now look at the real price of copper decreased greatly in year 1986, right? But increased greatly after 2000, mid-2000, right? The reason for this, China and previous activities. So manufacturing, copper facilities shut down, right, in earlier period. So figure 2.22, copper supply and demand. The shift in demand curve corresponding to a 20% decline in demand leads to 10% to 7% decline in price, right? Supply curve is like this. Demand in 1986, demand decreased greatly, shift from here to here. Because of that, copper price decreased greatly in 1986, right? This one can be explained. Real example can be explained, simple supply-demand curve, right? So at this time, more details than in section 1, right? We quantified everything. Equilibrium prices, elastic demand, like this. A pivot in the world oil market. Since the early 1970s, the world oil market has been buffeted by OPEC cartel and by political turmoil in the Persian Gulf, right? So now think about this, look at the graph. Real price of oil. So this one increased greatly in 1980s, right? And this in mid-1970s, and here. We can see increase greatly in here. But after that, in this period, it's decreased greatly. So why? Increase in early and mid-1970s. This is because of due to first oil shock. First oil shock happened in 1973. So price of oil increased greatly, right? Also, we know that second oil shock happened in 1979 to 1980. So real price of oil increased greatly here. Okay, and oil price also increased in mid-year 2000. Why? East Asian economies grew rapidly, including. So most important factor is the rise of China, right? So demand for oil increased greatly, so price increase, right? Okay, then we go back here. The OPEC cartel and the political events caused the price of oil to rise sharply at times. It later fell as supply and demand adjusted in this period. Okay? So after recently, price of oil also is adjusted fully because of shale gas, right? It's widely used in the found and developed in the United States. Okay, look at this. Because this example is set in 2009, 2011, all prices are measured in 2011 dollars. Here are some rough figures. 2009, 2011, world price of oil, $80 per barrel. World demand and total supply is 32 billion barrels per year. Among this total supply, 13 billion barrels is supplied by OPEC, right? So total supply 32 billion, OPEC supply 13. Then other competitive non-OPEC supply is 19. So 32 minus 13, so 19 is competitive supply. The following table gives price list estimates for oil supply and demand. In the short run, like this. Long run, 0.3. Right? In absolute terms, increase. Competitive supply, like this. Right? A graphical illustration of this. Now think about this is a short run effect. Maybe this is a long run effect. Right? When OPEC countries cut their supply of oil at world market. Initial equilibrium is supply and demand like this, right? Supply and demand curve in the short run, right? Total short run supply curve. This one consists of two components. Supply by OPEC countries, right? Supply by OPEC countries, this one, 35 minus this one. So that is 18 or 19, I forgot, right? And the other supply is competitive supply, isn't it? Right? So this one plus this one is here. And total demand is like this. Now, OPEC countries cut their supply. Then supply curve shift to the left like this. Then what happened? Price increase greatly. Right? Oil price increase greatly. So that is an example of the impact of oil shock. First and second oil shock, right? Like this. That is explained here. The total supply is sum of competitive or non-OPEC supply plus OPEC supply, right? Part A shows the supply, short-run supply and demand curve. So short-run is like this. Elasticity is smaller than long-run. If Saudi Arabia stops producing, the supply curve will shift to the left by 3.6 billion from here to here. In the short run, price will increase sharply. Part B shows long run curves. Long run demand supply curve is like this, smoother than before because long run elasticity greater than short run supply elasticity of supply, right? Demand curve also same, smoother than this. Okay? So part B shows long-run supply curve. In the long run, because demand and competitive supply are much more elastic, the impact on price will be much smaller. So same curve, same Saudi Arabia stops producing the same amount, 3.661. So from here to here, here to here, same amount. But the impact on price, anyway, oil price increased from here to here, but much smaller than price hike in the short run. In the long run, very small. Can you understand? Right? That is graphical illustration. But sometimes this one can be reformatted in mathematical one. Right? If you can find some chapter question regarding this on some quantitative one, then you can calculate mathematically all of this one. Right? in midterm exam, the first exam case, for example. Okay, let's go next one. Effects of government intervention, price controls. Effects of price controls. Without price controls, market clears at equilibrium price and quantity P0 and Q0. If price is regulated to be no higher than P max, so price ceiling, maximize each firm. So price cannot exceed P max. Then what happens? At P max, demand is QD, right? But supply by firms is Q1. So shortage happen or excess demand happen. Demand larger than quantity. Okay? So price control and natural gas shortages, figure 2.16. Price of natural gas. Real price. Nominal price. Natural gas price rose sharply after 2000 as the price of oil and other fuel. Why that happened? Because after 2000, East Asian countries, especially China's manufacturing, so industrial production increased greatly. So demand for natural gas increased as a result. Right? So price control and natural gas shortages. The free market wholesale price of natural gas was $6.40 per metric cubic feet, 1,000 cubic feet. Production and consumption of gas were 23 trillion cubic feet. Right? The average price of crude oil, which affects the supply and demand for natural gas, was about $50 per barrel. So supply curve of natural gas is QS is equal to like this plus 0.72. Price of its gas, its own price is plus 0.05 price of oil. Right? Oil and natural gas is close substitutes, so this is a positive. And similarly, quantity demand is equal to 0.02 minus 1.8 price of goods. Low demand set its own price impacts negatively on quantity demanded. Plus 0.69 price of oil, like this, right? So, as I said before, earlier, in initial point, free market wholesale price of natural gas was $6.40. This one, right? This one, initially this one is equal to $6.40. And price of oil was 50. This one is 50. Then we can calculate this one inserted here, this one inserted here. Then we know this one be calculated from this equation, demand and supply curve. That is equal to how much? 23 trillion cubic feet. Right? That is Q star, original Q star, PG star. And that is price of oil star initially. Right? Like this. And substitutes $3 for PG. But now price changes. This one is $3. Okay, I'd like to use blue one here. This one changes to $3 in both supply and demand equation, right? But this price of oil fixed at $50. Only price of gas changed to $3. Then this one inserted here. This one is 50 cents. Then we can calculate QS after, how can I say? Like this. QS changed to what happened then? Calculated this. QS is 20.6 trillion cubic, like this, right? And in demand curve, this one inserted here, right? $3 instead of $6.40 here. Then we can calculate the quantity demand again. This one is 29.1. Okay? So after government intervention at the market to fix some maximum price of $3 lower than market price, then what happened? Quantity demanded greater than quantity supplied. Okay? So excess demand or shortage is equal to Q hat D minus QS hat. This is equal to this one minus this one. So 8.5 like this. That is the impact of maximum price. Okay, so this is the ending point of chapter 1. I'd like to stop here. Okay, now we study chapter 3 of our textbook. Chapter 3 is consumer behavior, right? So chapter 3 and 4 covers household behavior, consumer behavior. Demand for goods decided by consumers or households, utility maximization problem. That is household part, right? After chapter 4, we have false exam. Okay, the structure of chapter 3 is like this. Title, consumer behavior. Corporate policy and public policy require an understanding of the theory of consumer behavior. The explanation of how consumers allocate income, household income, into the purchase of different goods and services. Right? That is an important thing, the key point of chapter 3. So I'd like to reiterate this one. How consumers allocate incomes to purchase of different goods and services. So household has income, right? That income is I. Household income, I, right? Households sell their labors and capital to firms, right? To sell their working to their labor hours and capital to firms and receive some money. That is income, household income. This real income is used to purchase goods and services from a goods market, isn't it? Right? So in simplistic model, we assume that there are only two goods. That is food and clothing. Only there are two goods. In real world, there are millions of goods and services. But we assume here only two goods, food and clothing. Right? So using this income comes from factors market. Factors market, households sell their labor and capital to firms. Right? At this factors market, firms demand labor and capital. Right? So using this income anyway, household purchase two goods, food and clothing. Right? And we assume that perfectly competitive market. Price of food at the market is PF. Right? Price of clothing is PC. Right? Using this income, purchase two goods. Right? So how consumers allocate income I to the purchase of different goods and services. So spending on food is PF and F. For example, household purchase two food and two food multiplied by price of food. For example, $2, then $2 multiplied by 2 units, then $40. That is spending on food, right? Plus spending on clothing, PC multiplied numbers of clothing, C. Right? That is total spending. So household demand for food and clothing at the goods market then requires some spending, right? This total spending or expenditure cannot exceed household income, right? In this simplistic example, from use all their income, then total spending should be equal to I. Right? This one is subsection 2, budget constraint. Right? Consumers purchase, demand food and clothing under the constraint that spending on two goods cannot exceed household income. So that is budget constraint, simply talking. Right? Two variables, food, clothing, and we assume that perfectly competitive market. So price of food, price of clothing, and income is just constant numbers, just given numbers, fixed numbers. Only two variables, food consumption and amount of clothing, like this. That is budget constraint. So if we think food is X, clothing is Y variable, then rewriting this, we can get budget constraint like this. Y, consumption of clothing, is equal to I over PC minus PF over PCF. Right? That is budget constraint. That is explained in subsection number 2, budget constraint. Right? Section 1, actually we study consumer's preference. What's the meaning of consumer preference? Right? Consumer preference is represented by indifference curve or utility function in microeconomics, right? So now think about utility function. Simplistic utility function is like this. Utility, anyway, there are two goods, food and clothing. Consumers' utilities is a function of amount of consumption of food and clothing. Food consumption and clothing consumption increased. Then household, consumers' utility increased. Right? Food consumption increased, total utility increased. This one increased, also increased, like this. That is utility function. Right? Utility function. And consumer preference means that the features of this utility function, simply talking, the shape of indifference curve like this. Right? That is section 1, utility function. That is 3.1. That is 3.2. Utility function in graph is like this. Right? X variable is C, Y variable is F. Then we can draw this kind of thing. Right? One of this one is, we said, indifference curve. Indifference curve. That means this one, UFC is, for example, 100 happiness. Right? This indifference curve means that consumption bundles of clothing and food providing consumers 100 level of satisfaction. Right? That is one indifference curve. One indifference curve. Right? This indifference curve also means UFC is, for example, 110. Food and clothing, bundles of food and clothing consumption or demand for food and clothing, right? Resulting in 110 unit of happiness, satisfaction. So a higher one prefer to lower one from the perspective of consumers. So this one means more simply U is 120, this one U100, 130, and we can draw lots of indifference curve. U is 80, utility level is 60, consumption bundles of two goods, food and clothing. So, I'm sorry, that is Y variable is clothing, X variable is food. Right? That is correct. So, consumption bundles of two goods, food and clothing, providing consumers $60 level of satisfaction, for example, like that. All of this one. Right? So, we said this curve, we said indifference curve. Definition of indifference curve is consumption bundles of two goods providing some fixed level of satisfaction. That is definition of indifference curve. Indifference curve for total utility is 110. Indifference curve total utility is 120, like this. Right? And we said all of this one is indifference map. Each one is indifference curve, right? Resulting in different utility level. All of this one is indifference map. Indifference map. And this indifference map is graphical illustration of this utility function. Right? Utility function can be illustrated like this. This indifference curve. And I'd like to explain what is consumer preference. Consumer preference means shape of this indifference curve, features of this indifference curve. Okay? That is consumer's preference. Consumers prefer higher indifference curve to lower one. Right? And one touch highest indifference curve, like this. Usually shaped like this. So that is some mathematical explanation required. Why shaped like this, right? But at this stage, I'd like to just give us some rough information for that. Anyway, today I'd like to explain the overview of Chapter 3 and key points, right? And after finishing this, then we study all of this one in more detail, right? So that is a rough view. And 3.3 is consumer choice. So what is consumer choice? Simply talking, mathematically, write like this. Consumers want to maximize this utility function, right? Consumption bundles of two goods. Consumers want to touch highest indifference curve. Right? Subject to budget. Right? So C equal I over PC minus PF PCF. Right? To solve this problem. Consumer choice is this one. Solve this utility maximization problem. To find optimal consumption bundles of two goods F star and C star. Right? Means utility F star, C star is highest one with this income level, right? So I'd like to summary again. Each consumer wants to maximize utility, right? Utility comes from more consumption of food and more consumption of clothing. So maximizing utility, right? More food, more consumption required. But there exists some constraint, that is budget. Consumers' spending, total spending, cannot exceed consumers' total income. Okay? So this one should be satisfied. Anyway, in this situation, find F star and C star, right? Subject to this budget, right? That is consumer's choice. That is the whole structure of Chapter 3. And Section 4, revealed preference. I said utility indifference curve is 130, 120, 110, and 100 like this. This one is indifference curve is derived in the sense that the numbers matter, right? The magnitude of numbers is matter. But in more general, we can say this level, this consumption bundles of two will prefer to this one like this. Just ordering matter in, right? But I use very strict version. So I said 130, second 110, 100 like this. Revealed preference means that we use just information of ordering. We can construct the indifference curve like this, right? Section 5, marginal utility and consumer choice. Marginal utility and consumer choice. So that is also, final version is this one, right? Solve this one to find F star and C star. The condition for this is slope of indifference curve. With the slope of indifference curve is marginal rate of substitution. That is equal to mu foot, mu clothing, mu clothing over mu foot, right? Is equal to PF over PC, right? That is a condition for optimal consumption. Marginal rate of substitution is indifference curve, slope of indifference curve, right? P1 over P2 is the slope of this Budge constraint. Then optimal consumption. That is optimal condition, first order condition of optimal consumption to go. Solution of utility maximization subject to Budge. Okay? And cost of living index is some index. You know, consumer price index, so wholesale price index like this. This one in real world can be calculated using some basic idea of utility maximization problem, right? So that is chapter 6. Okay, today anyway, I'd like to explain this one, right? This one, all over this one, all over this one, and rough some explanation of this one, the key points of chapter 3.